Okay guys, this is section 4.8. In this section our goal here is to be able to solve quadratic equations using the quadratic formula. So a little bit of vocab. Our quadratic formula, you've probably seen this before back in Algebra 1. So this formula is used to solve quadratic equations. So here we have the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So basically what we're going to do is pick out a, b, and c out of our quadratic equation and plug that into that formula to see what we get for our roots or zeros or whatever x equals. So let's do an example here. In this example, I'm going to pick out a, b, and c. Okay, my a is 1 out front with my x squared term, b is negative 6, and c is 4. So now I'm going to plug that into that formula. So it started off with a negative b, but my b is negative already, so it's going to turn to a positive 6. Plus or minus the square root of b squared, so negative 6 squared, minus 4 times your a, which is 1, times c, which is 4, all over 2 times 1, which is 2 times a. And now we're going to simplify that. So 6, and underneath the square root, negative 6 squared is 36, minus 4 times 1 times 4 is 16, all over 2 times 1, which is 2. And we're still going to simplify. So that becomes 6 plus or minus 36 minus 16, which is 20, all over 2. Okay, and now I'm going to think about the square root of 20. That could simplify. The biggest perfect square that goes into 20 is 4, because 4 times 5 is 20. So the square root of 4 is 2, and I'm going to smush together the square root of 5. So if this simplifies down to 6 plus or minus 2 root 5 all over 2. And since I have some even stuff going on, okay, I could divide 2 into everything. So it's going to be 6 divided by 2, which is 3, and 2 divided by 2, which is 1. I can choose whether or not to write it. And the square root of 5 is just tacked on there, okay? And again, I have 2 answers hidden in here. That's 3 plus square root of 5 and 3 minus square root of 5. Those both of the answers here. They mean the same exact thing as this first one here, okay? So there's our first example. Let's look at this one now. Okay, I don't have anything set equal to 0 yet, so what I'm going to do is move that 2 over here by subtracting it. So I'm going to rewrite it as x squared plus 3x minus 2 equals 0, and then I'm going to pick out a, b, and c, because my a is 1, coming from here, b is 3, and c is negative 2, and I can go ahead and plug that all in. So it starts out with a negative b, or a negative 3, since my b was 3. Plus or minus the square root of b squared or 3 squared minus 4 times your a, which is 1, times c, which is negative 2, all over 2 times a or 2 times 1. Don't forget all over 2 times something or whatever your a is, okay? Don't forget the fraction part. Then we're going to reduce that. So negative 3 plus or minus, well, 3 squared is 9. Minus 4 times 1 times negative 2 becomes an 8, okay, all over 2 times 1, which is 2, and we're still simplifying. So negative 3 plus or minus 9 plus 8 is 17, all over 2. Now I'm going to check to see, can I simplify that anymore? Well, no perfect square can go in the 17, so it looks like we're done here. So this is the simplified version of it as far as it can go. And again, this hides 2 answers, negative 3 plus square root of 17 all over 2, and negative 3 minus square root of 17 all over 2. They mean the same exact thing as this up top here. Here's another one, but it's not equal to 0, so I got to move some stuff around myself. I'm going to move the 12x to the other side by subtracting it, and I'm lining it up with the negative 18x since they are like terms. And I'm also going to move my negative 9 to the other side and make it positive. So this is going to become 25x squared. Negative 18 minus 12 more is negative 30x. And then plus 9, since we moved it to the left-hand side, equals 0. Now pick out A, B, and C. So A is 25, B is negative 30, and C is 9. So let's plug these in. Well, negative B. My B is already negative, so it's going to turn positive. And I'm starting with that square root, so B squared, or negative 30 squared, make sure you're putting it in parentheses, you're going to get a negative number, minus 4 times 25 times 9, all over 2 times your A, which is 25. Okay? So if I start to simplify, 30 plus or minus. Well, negative 30 squared, that's 900, minus 4 times 25 times 9. I like to think of this as 4 quarters make $1, or like 100, times 9 is $9, or 900. All over 2 times 25, or 2 quarters, make 50 cents, or 50. And if I simplify this, 30 plus or minus 900 minus itself is 0, all over 50. And again, square root of 0 is just 0. So I'm left with 30 out of 50. And these could both be divided by 10 to reduce. So 30 divided by 10 is 3, and 50 divided by 10 is 5. So I'm left with 3/5 on that one, or one single root, or 0, or answer for x. And here we have another one. Okay, I'm going to move the 5 to the other side. So I'm left with negative x squared plus 4x minus 5 equals 0. Picking out A, B, and C. So negative 1, 4, and negative 5. And if I plug these in now, well, negative B, or negative 4, plus or minus my B squared, or 4 squared, minus 4 times A, which is negative 1, times C, which is negative 5. All over 2 times A, or 2 times negative 1. So negative 4 plus or minus, simplifying 4 squared, which is 16, then negative 4 times negative 1 times negative 5. Well, that's negative 20, right? All over negative 2. And if I simplify that, well, negative 4 plus or minus 16 minus 20 is negative 4, all over negative 2. And now I got to think, well, can that simplify? Yeah, that can. If I take negative 4 and pull it out a second, that's the same thing as square root of 4 times square root of negative 1. Well, the square root of 4, that's a perfect square, that's just 2. And the square root of negative 1, that's just I. Okay, so I could simplify that down to negative 4 plus or minus 2i all over negative 2. Okay, and now since they're all even, 2 can go into all of them. So that can simplify down to positive 2, since negative 4 divided by negative 2 is positive 2, plus or minus I. Okay, and 2 divided by negative 2, that is negative 1, but it's being taken care of by that plus or minus in there. So here we go, 2 plus or minus I. And again, that's hiding 2 answers, 2 plus I and 2 minus I. Okay? All right, so not only can we use the quadratic formula to solve quadratic equations, but part of that quadratic formula can help us see how many and what type of solutions we're going to have before we even start. And what that is called is the discriminant, okay? So the only part of the quadratic formula we're going to look at this time is b squared minus 4ac. Ignore everything else, including that square root. We only want the b squared minus 4ac part, okay? So once we plug a, b, and c into that littler formula, if that discriminant is positive, then there are 2 answers, and not only are they 2, but they're real answers, or real numbers. If our discriminant was 0, then there's 1 real answer, And if our discriminant's negative, then there are two imaginary answers. So it's good to memorize. If it's positive, well, there's two real answers. If it's 0 or my discriminant's 0, then there's one real answer. And if the discriminant's negative, there's two imaginary answers, or x values, or zeros. Okay? And I will say, if we go back up here, what those really mean, okay, is if I kind of sketch this out, and I said my discriminant's positive, there's two answers, okay, that means there's two x values, or two zeros, or two intercepts, okay? They're crossing the x-axis in two places, okay? Then, if I were to kind of sketch out what the next one would look like, if my discriminant is 0, then there's only one real answer. Or it's crossing the x-axis one time. There's only one 0, or one root, okay? And then finally, if the discriminant's negative, then there's two imaginary answers. What that means is it's kind of floating around somewhere, not touching the x-axis at all. There's no zeros, okay, because they're imaginary. So for example here, what we're going to do is find the discriminant. And again, the discriminant was the b squared minus 4ac part, because we're going to give the number and the type of solution. So again, name out a, b, and c. Well, a is 1, b is negative 8, and c is positive 17. So b squared plus negative 8 squared minus 4 times a, which is 1, times c, which is 17. Okay, well, negative 8 squared, or negative 8 times negative 8, is 64. Minus 4 times 1 times 17, well, that's 68. And 64 minus 68 is negative 4. So here's my discriminant, negative 4. Okay, since it's negative, the number of solutions is 2, and the type, they are imaginary since the discriminant is negative. So this is two imaginary solutions. And there we go. Looking at the next one here, same thing, use a discriminant. So b squared minus 4ac. Pick out a, b, and c. So a is 1, b is negative 8, c is now 16. So b, negative 8 squared, minus 4 times a, which is 1, times c is 16. Again, negative 8 squared is 64. Minus 4 times 1 times 16, well, that's 64 too. And 64 minus 64 is 0. So my discriminant is 0. So the number of solutions here is 1. And the type is real solution, not imaginary. So there's one real solution on this one. Okay? So before I even go doing quadratic formula and graphing it, I know it's going to cross the x-axis one time. There's one 0 or one root. And last but not least, here again we have the discriminant one. So b squared minus 4ac. Picking out a, b, and c. A is 1, b is negative 8, and c is 15. So again, negative 8 squared, or b squared, minus 4 times 1, which is our a, times c, which is 15. Again, one last time, negative 8 times negative 8, or negative 8 squared is 64. Negative 4 times 1 times 15 is 60, or negative 60, excuse me, and 64 minus 60 is 4. So our discriminant is positive, so there are two solutions, and they are real. So two real solutions. So it's crossing the x-axis in two places. So there's two zeros or two roots. So this is how you can use the discriminant to even tell before you even graph it or solve for x, okay? How many and what type of solution is going to look like, and how it's going to look like on that graph before you actually go to graph it.